Okay, so we're looking at some sample data that you would have from the first lab, or the sample data, the rolling lab. Okay, sorry, I just had to make a little bit of a change there. Um, so what we have is the 5 repeated trials. These are the trials we did over and over from the same height down here, and the 8 individual trials, the ones we did up here. Okay, that's our goal. So we're going to take them and we're going to, I'm going to walk you through all the calculations you need to do and then make the graph and everything like that. And so at least you'll have all of the calculations um, ready to go. All right. And ultimately, you should be doing this with your data that you took today. Okay. All right. So the first thing we need to do is we need to calculate the value we're looking for, which is that I thing. And I gave normally you would have to come up with some of the equations for how to do it, but obviously in this case, I gave you the equations for it. So first thing is I gave you one equation, um, and that equation was that I told you, oops, that mass times 9.8 times the height was equal to I times m times v squared. Now I can cancel out the masses, but in order to find I need to know height and I need to know velocity. And actually, I should probably specify that's velocity final at the end. Okay, so I need to know height and I need to know v final squared. Okay, now height is going to be really easy to get because you kind of measured it directly. Although we'll have to do one little switch up for it. I'll explain that when we do it. And for v final, though, we're going to do some kinematics because we measured, right? We have v initial was 0. We had time, okay, and we had displacement. And so we can find v final from that. The best way probably is to actually do with a combination of equations. We actually don't have a combination um, of equations with these four variables. None of them work those four directly. But we do know that um, v average equals displacement over time, and it's also equal to v final minus v initial, or plus v initial over 2. And I can actually use this because I have change in x, I have time, and I have v initial. And this is 0 here. So if I solve for v final, I get 2 change in x over t equals v final. Okay, so the two things I'm going to do first in the spreadsheet is I'm going to solve for height, and then I'm going to solve for v final. All right, so we go back to the spreadsheet here. I still have time, height, and this. So here's the fun thing about spreadsheets. They can do all these calculations for you if you are careful enough. So the first thing is the height I had was that, oh, I did mess up. This should have been 11. I'm sorry. Is that these are my heights above the table. And remember, we measured the final position. So for me, the final position above the table where it ends up is the starting height above the table. I want the height above final position, okay, in centimeters. And the final position was 1 centimeter. So I'm just going to subtract 1 centimeter from each of these. And I could do that just pretty simple with, like, do it in my head. But I'm actually going to use a formula. To do a formula, you type equals, all right, and then you can select it. So I'm going to select this cell, -1. All right, and then I'm actually going to let it, here's the actual way you autofill if it doesn't suggest it, is you grab this little thing in the corner, pull down. All right, now I've got all these heights. These are heights above the final position. That's what I wanted, not the height above the table. Okay, next I'm going to find v final. Remember, I want, okay, and this is in meters per second. And if we go back for a second, it was 2 times change in x over time. So this should be equal to 2 times change in x over time. Now, the problem with this is that this is going to get us in centimeters. So actually, I probably should do this divided by 100, right? That's how you would convert from centimeters to meters, and then divide by time. Okay, I will let it autofill this time. I could have done it the old way. All right, so these are my velocity finals. And one thing, I mean, this is not a big deal, but I like to reduce the decimal places. I don't need that many decimal places. Like, that's good right there. That's totally a reasonable number of decimal places to have here. Okay, so I've got my v final and I got my height. So I'm going to go back to here. I know I've got v final, I've got height, I want to solve for I. So this becomes, right, it's 9.8 times h equals v final squared times I, which means that I is equal to 9.8 h over v final squared. That's what I need to do. I need to do 9.8 times h over v final squared. So this is going to be my I. And we won't bother with the units for that. Alright, so it's equal 9.8 times height. And I'm going to have to divide this by 100 again. So this divided by 100. Put that in parentheses. Okay, and make sure you have the equal sign at the top, otherwise, at the beginning, otherwise it's going to make you do it for you. And it's totally fine to do this sort of, these sort of calculations by hand before entering them. I find it a little easier this way, but some of the later stuff we do, you're going to have to do it by hand. So divided by v final squared, that's this to the second. And look at that. I get a bunch of values. And ultimately, I believe I was aiming for 0.7 was our goal. And so these look real nice compared, real similar to 0.7, especially if I, again, reduce the number of decimal places. That's good. That's a good number of decimal places. Okay. So that's the basics of the calculating the actual values here. And now we get into the statistics. And this is the stuff that you're going to do for every lab, the statistics. Okay, so the first thing we're going to do is we are going to try and figure out if the height above the table, so I'd ask for, yeah, the height above the table, so I guess this one, height above the final height, is related to I, if these affect each other. Okay, and that's because we want to know if I changes when you change the velocity. When you change the amount of energy in the system. Okay, it's a little bit tricky in this case, but typically I want to know on a lot of these labs whether one variable is affected by another variable. Okay, now to make a graph like that, you actually probably want to copy these columns out over here. And to do that, you probably want to do something called edit, paste special, and just paste values only. Okay. This is not absolutely necessary to copy it over here, but it's going to make entering or making the graph a little easier because when the columns are next to each other, it just makes it easier to graph. Okay, so I'm going to highlight that, insert chart. Okay, and it's actually going to select. So I want to make sure I have a scatter plot here. It did that for me automatically, which is great. I've got the independent variable. Height of a final position, and I've got the dependent variable up here. I might just change this to height, and I'm actually going to write this out. This is moment of inertia title. You don't need a title as long as you have, for me at least, this may not go for everybody, but for my class, as long as you have the two axes labeled, you don't need a I'm not going to require you to have a title for this. However, there are a few things we need to add, and there should be units. I'll put the units. I was going to be lazy and not put the units. I'll put the units here. It's kilograms times meters per second. Okay. All right. Put them in there. You should have units on both sides. I'll be a good get your initial height. Okay. So we got our graph. Two graphs right that. It's nice. It doesn't seem to change, but here's what we want. Here's where we have to add a couple things. All right, the first thing we need to go to series, because as much as this looks like it just kind of like stays the same as we go across, as we change the height, we want to actually have a statistic that tells us that. So we're going to go to series. Got it. Scroll down. You're going to add a trend line. Okay. It should be linear. But the only other things you're going to change the label to use equation. And you're going to check show r squared. All right. This r squared is 0.114. That's really low. That confirms what we thought before, which is that the two variables do not affect each other. All right. That's your graph. You're done. You made your graph. You're going to take that graph and you're going to plug it into your, or you're going to copy it into your lab report eventually. Okay? But we're done with the graph. That was it. So what we had to do again to recap, copy the two things we're going to graph, the columns over here, making sure we copy the numbers, not just the formulas. Otherwise, it's going to try and, that's why we did the paste special thing, the values. Otherwise, it's going to try and copy the formulas and you'll get some weird results. We made the graph, we labeled the axes, we added the trend line, and made it work up here. Okay? So we've got our graph. All right, the second thing we need to do is we need to calculate a few statistics. So we're going to have we're going to calculate the average. We're going to calculate the standard deviation. Okay? And then we're going to calculate the coefficient of variance and the z-score. Those are the four things we're going to calculate. You will always, so first thing is you will, if this r squared is really big, like above 0.75, like if it's like a 0.9 or something like that, you actually won't do any of these things, because they won't mean anything in that case. But because it's low, like 0.1, anything under like 0.5, you would definitely do this. If it's between 0.5 and 0.75, come talk to me, and I'll give you a little bit more guidance on it. Okay, we're gonna calculate the average of I. Okay, it's pretty easy. You can do it by hand, but especially you'll do it. Take equals, right? Equals just tells you want to do a calculation, and look at that, it's already doing it. But if it didn't autofill that, you would write just equals average, open parentheses. You highlight everything you want an average of, close the parentheses, hit enter, and you have an average. In that case, I did not want to autofill, but that's my average. Same thing for standard deviation. If you're going to write STDEV, open parentheses, highlight those 8 ones, those 8 trials, close parentheses. Make sure you do not highlight your average as well. Okay. All right. Now we need the coefficient of variance. Okay. The coefficient of variance is calculated by taking the standard deviation and dividing it by the average. All right, so equals standard deviation divided by the average. There we go. All right, and this is kind of like a percent. We'll talk more about this in class, but this is kind of like a percent. It's the standard deviation is kind of a measure of variance, and coefficient of variance is turning it into a kind of a percent. That's going to be useful because we're going to compare it against the percent error in our repeated trials. All right, next up we have the z-score. This lab requires a z-score. Not all of them do. So in fact, I'm going to do a confidence interval as well, even though a confidence interval is not necessary for this lab, but this is what you would do for it. A z-score is simple. A z-score is equal to, write it out. Okay, a z-score is equal to expected minus measured divided by the standard deviation. Okay, so I know what my expected value is, right? We said our expected value was 0.7 minus my actual value. Oh, I need a parentheses. So 0.7 minus my actual value, this, divided by the standard deviation. And that's pretty small. The negative part doesn't really matter. It can be negative or positive. It basically means that just it's whether you went high or too low. That doesn't really matter as long as we're close. The other thing to note about this value here that we've calculated is that you want it to be less than 2. Obviously, we're really far less than 2, so that's fine. And again, we'll talk more about what this means in class. Confidence interval is what would happen if you didn't have an expected value. A confidence interval is basically a range where you take your average and you add 2 times the standard deviation, and then you say, okay, and then you do the average minus 2 times the standard deviation. Okay, and basically you make a range between those two. So we'll have an upper bound and a lower bound. So really I should say confidence interval, upper bound and lower bound. Okay, so this, if I was doing it, it would be equal to the average plus 2 times my standard deviation, and then this would be equal to my average minus 2 times the standard deviation. This would be my, uh-oh, I messed up. What'd I do? F10, let me just start over. My average, okay, minus 2 times my standard deviation. Must have just done a misclick. There we go. Okay, this is my confidence interval from 0.6475 to 0.7562. Okay, so if this is if I ask you for a confidence interval, this is the calculation you would do, right? And if I ask you for a z-score, this is the calculation you do. And basically it's like, did I give you an expected value or not? Like in this lab, we had an expected value of 0.7, so we didn't need to do a confidence interval. We could just do a z-score. All right, the final things we need to do is we need to look at our repeated trials, at least math-wise. All right, you're going to calculate the average of each measurement, and these should all basically be really close together, right? So it was really easy for that one. The reason they should all be the same, really close together, is because we were measuring the same thing every time. 9.98 and time of this. Okay. All right. And then I'm going to calculate, so this is my average. Now I'm going to calculate my max deviation. And if you weren't paying close attention there, that's fine. What I was doing is I was doing the same thing I calculated earlier. I'm doing equals, typing in average, and then putting the opening a parenthesis, then highlighting what I want to do. Max deviation is basically the biggest of your values minus the smallest of your values divided by the average. So for this one, the biggest value I have is 30, the smallest is 30. So that's going to be 30 minus 30. Let me write this out. So again, it's, okay, max deviation is biggest minus smallest over average. Okay, so for x, it's equals, oh, sorry, that's not it. We're just going to do the max deviation is just biggest minus smallest to start. Okay, so it's going to be 30 minus 30. This one is 10.1 minus 9.9. And here it's the biggest is 0.516 minus 0.495. Okay. I did something wrong there? Oh, I did do something slightly wrong. This should actually be 0.508. I entered something wrong. Actually, 0.4. I entered a bunch of things wrong. This is 0.498. And this is, should be 0.501. Whoops. Alright, don't do that. Have your stuff entered properly. And then this is going to be now the biggest minus the smallest, which is 0.509. 508 minus, or 51 minus 0.498. Okay, 0.012. Okay, do one more thing. And this is where we're actually going to divide by the average. You take your maximum deviation and divide it by the average. Okay. That's still 0. Makes sense. 0 divided by anything. We're going to take our maximum deviation, divide by the average, and it's going to autofill it. And same thing here. We're going to take our maximum deviation. All right, and it's autofilling it like that. Okay. And so we're looking at these right here. And by the way, the part that's important is whichever one of these is the biggest. So this is very slightly bigger than that. So it's the most important one like that. So it basically would mean that time was our least accurate measurement. And ultimately what you're going to do is you're going to compare this, your accuracy of your measurements, compared to the coefficient of variance. Oh my goodness, I did mess up. All right, well that's fine. Sorry, no, I didn't mess up anything you should do. You're going to compare this to this. Okay, I should have left my numbers the way they were to start. They actually were more correct than this time. But you want this to be bigger than that, and this time it's not. So that's kind of unfortunate for this particular data set, but this is how you calculate it. Okay, so please try and calculate all those things on your own with your own data set. Set up a spreadsheet just like this, and you'll be in good shape.